Okay, this video is going to show you how to create an assembly file to create this assembly that will be used as part of the marking gauge assembly project. So you're going to launch Inventor and previously I have opened all of the marking gauge part files. So each one of those files is open here along the bottom. We're going to do a new assembly file. So File, New. You do want to make sure that you are in the English template, the EN English US standard. So do a new assembly, and if you were there already, you could have created that assembly back earlier. But just to double check, we're doing a new standard IAM assembly. So we're going to open that new assembly. I could create a project from this for marking gauge. I'll just simply do create here. And we're going to launch this new assembly file. Now, before you go on any further, it's important that this file, currently called assembly1, is attached to these parts here, and it lives in the same folder. So I'm going to File, Save As, and I'm going to save this in that folder that we have been using all along here for our parts. So I'm going to go to the TechEd, and I'm going to go into my students and navigate to that demo file I created for you guys for marking gauge. And in here where our parts are saved, we're going to call this the marking gauge MG assembly. Okay, so my marking gauge assembly is here, and it says, hey, it's not, that's just because I have another project open. And yeah, I want to continue to save everything there. Okay, so now we can get started with bringing our parts in to build our assembly. Now, assembly files are files that allow us to bring multiple parts together and combine them, or joining them, or constraining them together to build a overall system. And we can either do that by building parts within the assembly. So I could hit create here and build these individual components, and it will build a part file for each component that I create. Or if I already have part files created, this is what you've been doing, creating part files, I can place those part files. And since we've downloaded some part files, we're going to place them. So I'm going to click place, and I am going to navigate to that folder that I had been using all along, where I have it saved, my students directory here. So students, that's 2, my name, and my sample. And I'm going to place each one of these. I'm going to start with a beam. So we'll put the beam in there and just simply say open. And I'm going to click out here on the screen. Even if it's not the view that I want, I could rotate this around. Now, it allows me to put multiple beams. I only need one. So I'm just going to place the one. Come back up here to place, and we're going to do this to each of our files. Again, it's looking at a project that I've been doing for robotics, so I have to navigate back. It will keep yours. So I'm going to go down to students, my name, and I'll have to do this for each part, unfortunately. But you are going to place those parts, each one of them. Just simply place them. So we started with beam, we got head. Place each one out on the screen. You only need one, with the exception of the knurled screw, where you're going to place 2. So you place it, you click on the screen, and then you hit escape. And again, go back and get the knurled screw. And I'm sorry, I got to do all this navigation. Okay, because the active project I have open, so you didn't have to see me constantly re-navigate through the directory, I have added all those parts in using the place command. So now that you have all your parts there, we're ready to start to join those together. So when you're joining together, one of these parts needs to be grounded or needs to be anchored, and everything is going to rotate related to that. Since these parts slide on to this beam right here, or thread into it, the beam will be our principal part. The beam is going to be the one that we're going to anchor or ground. And so what you want to do is select that part. You can either do it out here in the modeling tree, select it out there, or you can click on it out here. With that part selected, then right click, and you'll get this list here. If you go about 3/4 of the way down, you'll find the word grounded. And so you want to check that box and ground that out. What that does is it puts a little thumbtack over here, and it says it's fully constrained. And you can just double check. You see this little check mark here. This is a grounded part. This part cannot move. I can't click and move this anywhere. These guys I can move around. I can free move them anywhere I want to put them. This part is grounded. Everything has been anchored to this part. And so now we're ready to constrain our other parts to this grounded part. And so we're going to use this view cube here to flip around to try to achieve the directions that we need. And if you notice right here, this flat area on this beam, this receives the heads of these screws to hold this head piece in place. So the head slides onto the end here. The screw then threads down and clamps it in position. There's another screw that comes into the end. There's a scribe that comes through here. So our assembly of our marking gauge is this right here, and this device is designed to scribe a parallel line to an edge. And so we would set this at a distance, maybe let's just say 5 inches. And so you would loosen your screw, slide this in, measure 5 inches to the point here, and then that part would slide on the edge, and you would scribe a parallel line. So that's what the use of a marking gauge is, and these parts make that happen. So this part's designed to move up and down in here. The scriber is designed to, you can get a little deeper into your material or less deep by over here. So these parts are going to be fitted into here, and we're going to do that using a relationship. We're going to specifically use the constrain relationship. And one thing I want to mention is use constraint and use your view cube to get parts to go where you need them to go. Never use free rotate. We're just going to constrain these into place. And so we're going to start with an insert constraint. That's the 4th option over here. Insert. And I want you to pay attention to the solutions here of these arrows, as they're going to matter when we're setting this up. So I'm going to do an aligned solution. I'm going to do an aligned solution, and you see the 2 arrows are aligned. And what I'm going to align to, if you notice when I mouse over this part, click on this end circle here, right there, the end of my part, and there's an arrow at the center there. I'm going to click on that, and it's that arrow that we're aligning. And now we need to pay particular attention. The scriber hole is down here, so this head needs to be facing facing the other direction. And we're going to do that when we select this hole. We can choose which end, and so this is the end that needs to be set up or needs to be aligned. So this end, that arrow right there, is what needs to be aligned. And when I click on that, it snaps into position. And you will see that that is aligned here to the end. Now, it's not exactly where I need it to be in my drawing. And so you can go back and look at the drawing here. It doesn't have a set dimension, but this is approximately 1 inch in from the end. And if you look here, we're about 1.5 inches on the head. So from the end here, we're going to slide it another 1 inch. And we can do that using this offset over here. Now, I think it's a negative distance, negative 1 inch, and that is correct. So you just type a -1, and then that moves in 1 inch there, and you just say apply, and really that could be a set distance wherever we need things to go. So that part's been constrained in there. We're going to use the insert constraint in a similar way with the scriber. So the scriber, I'm going to use an aligned as well there. And I'm going to take the end of the scriber, and I'm going to come down here to the hole, the top of the scriber. Now this one, we're going to do a negative offset of 0.125. So take your negative offset 0.125 and that pulls that back out. I'm going to click apply there. Okay, so those two parts have been placed. Right now you can see that my head can still spin on here, but it won't move back and forth. And I can spin it and I can sort of align it so that this work axis is aligned to this, but that really will come into play later on here. So now our screw. We're going to use a mate constraint to this flat surface. So take a constraint here. We're going to take this mate and we're going to take the flat face, not the edge. Do not do the edge. Don't do this. We're going to take this flat face right here. And that flat face has been selected. Just simply select the flat surface right here. And that screw will go in and we're going to apply that. Now to get that screw to align to our work axis, we're going to use a mate there as well. So we got a mate, and this axis, this line that runs through here, that is going to align and move our screw into position. So constraint moved all this around. I didn't have to drag that. The constraint that aligned that, it rotated the head into position, and I can click apply there, and so you can see where that all fits into place. Now the very last constraint with this screw here is going to be very similar, but instead of a mate, we're going to do a tangent constraint. So we're going to use this third constraint right here, tangent, and we're going to be tangent to the outside, and we're going to make it tangent to this scriber over here. So just so we can see this a little better, I'm going to turn this part so its visibility is off. So I'm going to take the beam here, right click on the beam and turn its visibility off so it went away. So I just turned visibility off, and the beam's still there. It's just been quieted. So now our tangent constraint, and we're going to go tangent with an outside solution. We're going to be tangent to this surface, and I'm going to turn my screw and select that face right there. Don't face the edge, take the face. And that put that in approximate position. I want to say apply. Now I can turn my beam back on. So right click over here and go down to your visibility and turn your beam back on. So that's in position, but you will notice that I can still move this out. And so I want it aligned properly. And the last constraint we're going to do is a work constraint. We're going to mate, and we are going to mate this work axis right there with the work axis of, and we're going to do opposing the work axis of my screw. They get aligned, and then just simply hit apply. Now your marking gauge is ready. It is assembled, and it's ready to work with further. Be sure to take this assembly and save it. Make sure you save it in that directory file. Now if you just do a save, because we saved it in the beginning as marking gauge assembly, it should save right there. Or you can do save as and double check that you saved it in the same folder all these other parts are saved in. Make sure it's saved there. Now we're going to move forward and show you how to put it on a layout.